Hi. Well, thank you all for coming in this morning so early for our initial keynotes and braving the bicycles, which go very fast in Amsterdam, don't they? So my name is Anne, and I'm the CTO of Microscaling Systems. As was said in my very kind introduction from Seth there, it was extremely pleasant introduction. It couldn't have been better had I written it myself. There you go. So what I'll be talking to you about today is basically the power of orchestration, particularly for containerized workloads. And I'll be getting to it via a rather roundabout route, but that is fundamentally what I want you to take away from this, that this is a new world. It's absolutely a better world for ops, for infrastructure. And I personally can't wait until we get there. But the roundabout way I'm going to take you to this today is to talk to you about a performance indicator in technology, which never quite gets to the point of key performance indicator, but I would like it to. I think it's more important than we're potentially giving it credit for. And that performance indicator is resource efficiency. And I think it's due for a comeback. And I think it can make a comeback. I think it will do very well, particularly in an orchestrated environment. So what do I mean by resource efficiency? I mean the efficiency of the way in which we use the underlying resources that our applications run on. So CPU, memory, bandwidth, and then underlying all of that energy, electricity. Is it good enough at the moment? Well, at the moment, Gartner did a study about a couple of years back now, but I think it still holds, saying that the average data center usage worldwide was about 10 to 15%. That really doesn't sound very good. But maybe it is. Maybe that's the best we can ever do. Maybe you're never going to get better than 10 to 15%. But actually, you can do better. If you look at industry leaders in this area, like Google or Netflix, so Netflix are managing over 50% utilization of their resources, and Google are managing over 60%, 60, 65%. And if you were at Diptanu's talk yesterday, you'll know that with an orchestrated environment, 60% is not an unachievable goal. And as he said, we'll never get to 100%, we'll never get to 90 or even 80% because it's too difficult to do that. But 60%, I'd be happy with that. I'd be more than happy with that. That's still 4 or 5 times better than we're managing on average now. And there are lots of interesting reasons why it's important, potentially, that we do better with this. Mitchell gave a very interesting keynote yesterday, and one of the things he pointed out was that what business is really interested in is being faster to production, getting features and products faster to market, not resource efficiency, not cost savings. And I think that's very interesting, and I think he's entirely correct in that. So resource efficiency is suffering for that because it is not the most important thing to businesses at the moment. It's a nice to have, it's not the most important thing. But actually, there's good reason why it should be more important to us. So why do I think it's a problem? Well, when I started to look into this, I realized that we actually use a great deal of energy in data centers in the IT industry. Data centers, according to The Economist last month, data centers use about 2% of worldwide energy use, which is a lot. Or is it a lot? Who knows? 2%, is that a lot? So the first thing I did was look into what other industries use, how much energy other industries use. And the most obvious one to compare it with, interestingly, was the aviation industry, which, according to my researchers, uses about 2.5% of worldwide energy. And that's quite interesting, because people campaign against the aviation industry. They consider it to be a very high user of energy. People think twice about making unnecessary flights. They campaign against new runways. But we don't campaign against new data centers, although actually there has been some movement in that direction. I think that might be coming. And that isn't really fair, because the aviation industry is a massively energy-efficient business. It's incredibly important to them that they don't waste any power, because it's a big part of their costs, and they compete, most aviation companies do compete on cost. And they're under an awful lot of society pressure to do better, because they're seen as polluters. And we are under neither of those. As Mitchell said, cost is not one of the things that's massively pressing on us at the moment, and society has absolutely no idea what goes on in the data center. So nobody ever says, oh, well, I'm going to use WhatsApp, I'm not going to use Snapchat because WhatsApp is more energy efficient than Snapchat, because they don't know, and I don't know, and who knows? We just don't make that kind of decision. And from an ops perspective, I am massively happy that nobody is camping in my front garden protesting against my bloated app or inefficient SQL queries. Thank goodness they're not doing that. But at the same time, as a human, as a Terran, I feel that perhaps it would be a good thing for us to be under a little bit more pressure there. The fact that we're under no pressure might not be a good thing for the world in general. Not least because there are new threats on the horizon that will be coming up to challenge us further on our use of data. The first is the Internet of Things, and by that I don't mean intelligent fridges taking over the world. I mean there'll be a lot more smartphones, there'll be a lot more tablets. And I've seen projections that demand for data centers might double, or it might even be as much as 4 times what it is now by 2020. And if we continue with our current way of using data centers, then we'll be potentially using really quite a large percentage of the world's energy just to run data centers quite inefficiently. Which I don't really like the idea of. And microservices, I know we love microservices and we love the concepts and we love the architecture, but actually they're quite a threat to us from this perspective. From this perspective, and I'll be talking more about that later. They are not an unalloyed good. Microservices go very well with orchestration, they go very well with containerization, but without that, there are some risks associated with them. So, before I talk to you more about what we can do about this and what our options are, I'm going to take us a little bit back to the story so far, which I think is very important because it helps us to understand how we got here and how we might move forward in a way that is psychologically aligned with our behavior in the past, because nobody ever behaves completely differently. Industries don't behave entirely differently to how they've done previously. So resource utilization hasn't always been an underperformer. Sometimes we've done really quite well on it. So Moore's Law, which I don't really need to tell you anything more about, massively improved the bang for our buck on hardware. So I think we have solid-state physicists in labs all over the world to thank for that, and I do. That made a huge difference. So great. We were absolutely winning there. That was fantastically good. But then we came across our first opponent in how we used our resources, and that was developer and operational productivity. We didn't use all of the gains of Moore's Law in order to just be cheaper, to use less energy, to have smaller data centers. We used one heck of a lot of it to make our jobs easier. And I can't really complain about that. We produced tools that made us go faster. We used less, more verbose, more human-readable protocols for going over the wire. And that made us considerably faster. And as Mitchell said yesterday, faster is what we're generally looking for in the computing industry. We're not so interested in costs. That doesn't come up. We really, really want to be faster on the production of new software, new features. So am I saying that dev and ops productivity is a baddie? No, I'm not. I would not want to go back to the 90s. I wouldn't want to go back to a world in which it took weeks, months, years to produce software that we could now produce in hours or days. It's not a world I want to go back to. And it would be a bad world because software has immeasurably improved our lives. I would not want to go back to a world in which there was very little choice, there was very little progress because we were moving extremely slowly. So dev and ops productivity, it's not a baddie, it's a goodie. But maybe I wouldn't, but it's winning quite hands down at the moment, and is that a good thing? So, yeah, again, productivity has had some other wins other than resource productivity has had some other wins other than just hardware. If we put hardware to one side and we say hardware just keeps getting better, although that is slowing down now, then there are other ways that we've found to use our machines more efficiently. And the first one is the logical thing. Back in the days of physical machines, if you were running a really tiny application on a huge box, that was massively inefficient because it was only using a tiny bit of the resources, and the rest of it was on, it was turned on, it was powered up, it was taking up space in your data center, you were having to cool it, but it wasn't actually doing anything useful for you. Now, one way to handle that would be to just buy smaller boxes for your smaller applications. But logistically, that's a gigantic pain in the neck, so nobody wanted to do that. And this time, we have computer scientists in labs from the 60s onwards came up with the incredibly clever idea of having virtual machines, which you could use to divide up the resources on your larger physical bare metal devices. And this was an astonishingly clever idea. Rather than just either having to buy a huge range of different machine sizes or sacrifice machines by having lots and lots of spare capacity sitting around unused, we could actually start dividing up how we were using our machines and kind of tessellate, jigsaw pack applications onto a single machine. And that was absolutely fantastic. Led to much better efficiency. And of course, back in the days, 10 years ago, when we were still running physical data centers predominantly, there was another extreme advantage to being more resource efficient using VMs, which is that it was a huge pain to put in new physical machines. It was a huge pain to expand our physical capacity, our hardware resources, because you had to put new machines into your data center. There might not have been room for them. You had to get the additional power. It might take weeks or months to order them. So it was a giant pain point. So we were highly motivated to use VMs effectively. And I think that was phenomenally important. It's a big, what motivates people, what is the pain people are experiencing is a good reason, is a good sign of what they're likely to do, how they're likely to behave. So everything's great. So we're saying VMs have won, we've won. It's a total that we never need to worry about resource utilization ever again. It's fantastic. But no, unfortunately not. That is not the way that things turned out. Because the cloud came along. And I'm not slagging off the cloud. Obviously, I'm not slagging off the cloud. I'd be crazy. But it did change things about how we used resources, and it changed where our pain points lay. So when you're running a physical data center, it is a pain to put in new machines. But one of the things the cloud did was take that pain away. It costs you money to ramp up additional resource in the cloud, but as we've proved, and as Mitchell effectively alluded to yesterday, money is not the pain point to us that our time is, that operational productivity is, and the actual pain of having to do really horrible things like find additional power for machines and data centers. So a lot of our motivation to use resources more efficiently is removed if we go to the cloud, because we can just buy additional machines and it's not the end of the world. There's another slightly more subtle effect of moving to the cloud, which is, if you go to AWS, which is where most of us are running our machines, the availability of VMs is not all that granular. You've got kind of small machines and medium machines and large machines and super extra large machines, but you don't have millions of machines. You don't have tiny granular selection of VMs to choose from. So when you're running an application, you have a decision to make. Am I going to run it on a machine that's too small for it? Well, probably not, because then it will fall over. So I'm going to run it on a machine that's too big for it. Or maybe, if I'm being very careful and I'm not entirely sure what resources it might require, I'll run it on a machine that's way too big for it. So almost by definition, every time we deploy something, we are over-provisioning. And actually, a couple of enterprises have talked to me recently about how they got an awful lot of benefit from just going through and doing a manual exercise of sizing down their VMs, looking at all of their applications running in the cloud, seeing whether they'd over-provisioned on their VM sizes, and they saved quite a lot of money doing that. And although I know that money is not an object, seemingly, it's potentially a quick and easy win to just go and take a look at your VMs, potentially size them down. So the cloud, good, but for utilization, not really an unalloyed good. So why isn't DevOps just fixing this for us? Because we know that DevOps is amazing and DevOps fixes everything. And to a certain extent, DevOps, well, in this case, DevOps is helping us manage the very large number of machines we now operate. DevOps is absolutely fantastic at that. We would not be able to do what we do now, I think, without effective DevOps. But it's not focused. I mean, there will probably be clever DevOps folk out there who are doing this kind of thing, but generally speaking, it's focused on allowing you to manage a very large number of machines and scale up. It's not necessarily focused on you cutting costs and using your resources more efficiently. Microservices, they are a very interesting concept. I love the architectural concept behind microservices. It's clearly the correct thing. Simpler applications take an awful lot of the complexity and the intelligence out of individual monolithic applications and move it somewhere else. But there are downsides to it. There are risks to a microservice approach. You've got more instances, and as I've previously said, the more instances you have, the more potential you have to over-provision every single one of those instances. So there are potential risks associated with that. There's also, it's just a very, potentially, as it scales up, a very complex system. And we have kind of got into the habit of managing complexity and keeping things resilient in the face of complexity by over-provisioning. And that is not crazy talk. That really works quite well. Over-provisioning is a very quick and easy hack for giving your systems more stability. So in a more complex system, it makes sense to over-provision. And also, we've moved an awful lot of we've separated monoliths, which could be really quite resource efficient in what they did. They often had a lot of internal scheduling, they had internal queues, and they were very complicated and clever and did all kinds of clever things. And that's exactly what we're trying to stop. But in some ways, that was quite useful. And it often did quite a lot of stuff to help us with resource utilization. So moving to microservices, it's good, but again, it's not an unalloyed good. It has its issues. So are we now saying this is a disaster, this is the end of the world, there's absolutely nothing we can do about this? We really want the cloud, we really want fast production of features, we want that developer productivity, we want that operational productivity. Resource utilization will just have to be sacrificed to that. There's absolutely nothing we can do. Well, if only there was some kind of technology that existed that allowed us to do some of the same stuff that VMs does in terms of boxing up applications and assigning resources within a larger physical machine to a particular application. If only, but maybe in a lighter weight way, maybe without all the overhead of a hypervisor, maybe directly within the kernel. And because it was so lightweight, it would be easy to move from place to place. It would be easy to switch off and switch on, make more granular, possibly even resize as we went along. If only such technology existed, that could potentially save us. Containers. Of course, that technology does exist, and we're all very familiar with it. Containers allow us to do that kind of resource assignment that is done by VMs, but in quite a heavyweight way, in a very much more lightweight fashion. Containers are not VMs. There are other benefits to VMs. They're a lot more hardened. They're a lot more potential. They're secure right now. They have features that containers don't have, the ability to run on any host operating system you want, that kind of thing. And there's loads of tooling available for VMs. But containers do have the incredible lightweightness and ability to resize themselves in effectively real time that VMs don't have. And of course, they do that. You know this as well as I do. Do that through namespaces and through C groups. So Unix kernel functionality, which is intellectually very easy for us to understand. You can say, right, the kernel's saying you can do this, but you can't do this. For an application, or for a process or a group of processes, you can have access to these resources, but you can't have access to these resources. It's very, very straightforward. And in fact, it seems incredible to think that we went through so many years of Unix and Linux and Windows without that functionality in the kernel. And of course, if only, again, on top of containers, we had a way of using containers that was a common API that allowed us to put kind of easy grip handles on our containerized applications and move them from place to place. So we could write really cool tooling that would enable us to take a given application and move it from dev to test to production, and then move it around in production to where it fitted in best. If only that kind of technology existed. And of course it does, Docker. They've done a fantastic job of being almost the killer platform for Linux containers and the killer application for Linux containers. They showed us why they are good. By being a fantastic, Docker being a fantastic packaging application and a set of APIs for Linux containers. And of course, it's easy to believe that containers only existed when Docker came on the scene in 2012, but containers themselves have existed a lot longer. And they were invented not for packaging, not for what Docker does, but for effective resource utilization. They were invented by people like Google and Sun in order to use their resources more effectively. And these guys, like Google, are the masters of doing that. So they have done extraordinarily well at using containers to use their resources much, much more effectively, cut their costs, and provide all the other good things you get, which I'll get to later. So Docker and containers, that's absolutely fantastic. But it's kind of limited in its scope. You're almost talking about using a single machine. What we've been talking about up till now is using a single machine very efficiently and very effectively. But wouldn't it be good if there was some kind of tool that was available to us that would not just have that single machine vision of the world, but actually have a more holistic vision? Be able to think not just about a single machine and how that was used, but think how your whole data center was used, or even multiple data centers. It would be amazing if tools that could use Docker, could use the Docker APIs, could use the Docker packaging format, could use the lightweight nature of containers and our ways of parceling off applications and putting a little box around them so that you could use an individual machine more effectively, and taking that and using it on a much larger scale across your entire estate. If only tools like that existed. My God, they do. And finally, we're at Orchestrators. And there are lots and lots of orchestrator tools out there that are in a very good state and will allow you that kind of power. And don't get me wrong, this is power that has never existed for us previously. This is new, and this is something that we can do to completely revolutionize how we run our data centers in the future. Nomad, you've heard a lot about today, obviously, yesterday, obviously. Kubernetes, another extremely strong contender from Google who's kicked this all off, basically. Mesos as well, and Swarm from Docker. All of these are really useful tools, and they all have one very interesting and useful thing in common, which is that they have an API. They have very clear and easy to use RESTful APIs that sit on top of them. So all of the power that they have, knowing where everything is, knowing what's running across your entire data center or multiple data centers, and being able to control it, if it's containerized, if it's Dockerized, you have that power. You can install orchestrators, and you can start to use that knowledge that they have through their standard APIs. And that is fantastically powerful. And it's really the purpose of this. I think in the end, what we're aiming for here is intelligent infrastructure. It's infrastructure that does more than just run what you tell it to run, but actually makes decisions about where should I run this? How should I run this? When should I run it? How can I make sure that it stays resilient? How many of these things should be running? I'll just look after that for you. How quickly should this run? Do I need more of these? Does it need to scale out? I'll just look after that for you. That's what we're talking about with intelligent infrastructure, and it's what orchestration and then the kind of custom tools that you can write on top of orchestration will deliver for you. And it's a fantastically interesting world. Efficiency, resource efficiency is just one of the things that it potentially delivers. And as I've said earlier, I think that resource efficiency is the most important thing that it delivers, but that is not generally true. You should never sell it to your boss that way, because businesses, they don't care about resource efficiency, really. It's not a bad thing. They're quite happy to have it as a side effect, a happy side effect, but what they really want is more operational and developer productivity. They want to be faster to market. And so orchestrators, they do provide that. The fact that they will be managing your systems for you, making them more efficient, making them more resilient, making them more fault tolerant, is all about operational and developer productivity. And that is always the way you should sell orchestrators. But just between us, we should know that what we're really doing it for is to save the world. But we'll just have to be a bit Clark Kent about the whole thing and say we know that we're saving the world, but we never tell our bosses. We can maybe tell our mothers, but we can't tell anybody else, because that's not what sells to enterprises if you're selling it up within your organization. Sell it on the other benefits of orchestration, which are increased automation, which is also another great benefit of automation, of orchestration. So let me, could I get you to queue up the demo? So I'm not running a live demo here because I've got enough white hairs. So thank you very much. So I recorded this on my machine the other day, and I wanted to give you an idea of the kind of thing that you can write on top of an orchestrator. And this is a custom scheduler. What we did here, because obviously we wrote this actually a while ago to see whether or not what we were talking about in terms of very clever applications and tooling that can run on orchestrators was actually true. Because who knew? Back then, in those days, people talk the talk, but really, is it actually true? So what we did was we wrote a very basic scheduler in Go, and we told it we're going to fake up some simulated demand. And the simulated demand is in red here. It's the red line. And we said you've got two container types. And they were very just simple BusyBox containers. It wasn't real load. But this was a simple thing. We wanted to see whether it worked. So we said that you've got two container types. You've got a high priority container, which is demand dependent, which is latency sensitive. And that's the dark blue container count there. And then we've also got a second container type, which is important to us, but not critical. Maybe it's a batch process. It's something that is less demand sensitive. We want it to run. It's important, but we don't really care. We don't care so much about when it runs. And what we told the orchestrator, what we coded, what we instructed the custom scheduler to do was we said, meet the demand, start enough containers so you meet the randomized demand. You don't know what this is going to be, and then do what you can to fill up the rest of the resources, and we'll tell you how much there is, with these lower priority containers. So meet the demand and then fill up the rest of the resource. So you've got two goals here. One, your primary goal, meet the demand. Your secondary goal is to use all the resources that are available. And then we set it off. And you can see there's a win. It's winning there. Oh, it's just gone off there. There, it's winning there. Winning there. It's just gone off. Winning there. And we ran this, and we weren't entirely sure whether or not this would be true for all the orchestrators or on all platforms. So we ran this with all the major orchestrators, and it behaved in pretty much the same way. And all of them have very good REST APIs that you can use to do this. We also ran it against Docker directly on a single machine. It worked reasonably well. We ran it on EC2, on Azure, and on bare metal. So again, there's nothing magic about the underlying hardware, the underlying physical devices that you're using to run this kind of custom scheduler. It will just work. And it's only a couple of hundred lines of Go. It's probably actually now about a couple of thousand or so lines of Go. But it's not hugely complicated. This is something you can do. And if you make this analogous to your business, because I used to be in eCommerce, maybe the high priority containers are something like your web server, dealing up with real-time customer requests, and the lower priority services are something which is important to you, but like batch process, like data analysis, you need it to happen, maybe Bitcoin mining, you need it to happen at some point, but you don't really care when it happens. So I think what this does is prove that there is some interest to this. There are interesting things you can do, and they are not impossible to do. Once you've got an orchestration layer in, it opens up a huge world of interesting tooling, interesting control you can start applying to your data center. And with containers, this is kind of a real-time operation. It's not machine real-time, but it's kind of human real-time. And if you're running since most of our customers are humans, that's actually useful enough to be getting on with. Could you wind on to the next slide? Thank you very much. So that's all really, really interesting. And most of what we have, most of what we need to do this is already in place. It's already there. Docker exists, containers have existed for a long time, and they're stable technology. Docker exists, and it's existed for a long time, and a lot of us are already using it in production just for deployment. So we know it's a fairly stable technology. Orchestrators exist and are being used in production. This exists. This is not crazy talk. But everything that we need isn't there. If we're going to make intelligent decisions by custom set schedulers like the last one we saw, then we actually need to have it's the easy bit that we haven't done yet. We need to have some metadata associated with the container images that we want to run, so we know what's an important image and what's a less important image. What is your web server? What's your batch process? What should be in production? What actually should only be in dev at the moment? Who owns this? What's going on? All of that metadata at the moment is not very commonly associated with images, and I think it's a habit that we need to be getting into, because we will not get this world of amazingly clever tools. Hopefully I'll write some of them, but most of them will be written by you guys if we don't have metadata that lets us look at a container and go, okay, right, this is the kind of thing I can do with it, and this is the kind of thing I can't do with it. Now, this technology already exists. Docker labels is, I think, the right way to do it. It's already built in and part of the Docker API. You can it's been in since Docker 1.6. The format is just a key value, free text format for saying, here is my key name, here is my key value. And you can find out what the format is on the, what the free text format is on the Docker website. But basically, it's free text, and it's a key value store, key value type format. The problem with it is that we haven't yet specified any schemas for this data. If we really want to get an awful lot of power out of being able to know what a particular container image can do and should do for us, maybe what its limitations are, what, as a developer, your intents for it might have been, then we're going to need to do some schemas so that we know what we're looking for when our tools are running. We can say, I know that this means this and this means this. So that's actually very simple compared to everything else we've done to get to this point. This is a tiny further step for us to make. And so Microscaling Systems, in association with several other vendors, are trying to get to some schemas set up for this. We've set up labelschema.org for you all to go in, take a look. We've done almost nothing thus far. We've tried to keep it very, very, very basic, so we're not over-egging it. There are some of the vendors have done some quite good work in this field, people like OpenShift and Kubernetes. But the schemas that they've come up with have tended to be very focused on their individual applications, and which makes perfect sense. What we really want is more generic metadata to go onto images so that we can all start writing our own little tools like that custom scheduler or any other custom scheduler that you could think of, and start controlling it and looking at the metadata and seeing what we can and can't do with a particular container image. So in order to get the ball rolling on this, we've set up a site, and we're doing a soft launch of this today. Literally went into production at 12:30 last night. I had a quick look at it this morning. There are some bugs, but go on there and have a play around. It's not completely finished, but it's ready to play with. And what we tried to do here was to give you a soft introduction to labeling your containers. So what this does is once you've is that we've defined a schema in labelschema.org, a shared schema for everybody. Everybody can use this, which allows you to say for a particular container image just what the GitHub source was for it. So it's all about linking a public Docker Hub image with the public GitHub source that it was built from, which we thought was probably the easiest and most useful first example of tagging a container image with a bit of metadata. So and it's amazing, very few images have any metadata associated with them at the moment, less than 20%. By Gareth Rushgrove from Puppet's done some investigation into this, and he thinks it's less than 20%. And that's a real shame, because it's easy to do, and it's so enormously useful and powerful. We won't get this clever, intelligent infrastructure world if we don't start doing some of these things. And they're very simple to do, and they're fun. They're fun. There's no problem with them whatsoever. So go on to microbadger.com and badge your container images. And yes, I said tomorrow because I think we're actually officially launching it tomorrow. But feel free to play around with it today. There are a few missing images, and there's some other stuff that's a bit, but it's perfectly play around withable. And join us. Go to labelschema.com and .org and start telling us what you think should be labeled against containers. We've already got some quite useful feedback about things like how long this image should be backed up for, because I'm already talking to folk who have hundreds of thousands of images sitting in their repositories, and their image repositories, and they have no idea which one of those images should be backed up now, which ones are just dead because nobody's labeled it. And labeling is the obvious way to do that. So everything I've talked to you about today, it is not trivial. It's not something you're going to be able to figure out in 5 minutes with a quick search on Stack Overflow. It is similar in effort to the effort that we had to go to learn about VMs and VM orchestration in the first place. But I think that we would all agree that that was effort that was well worth making. And it's good to take the same kind of approach we did there, whereas we learned about it in dev, we learned about it in test, and once we got our heads around it, then we put it into production. Orchestration is similar. There's lots of new concepts to learn, but like VMs, there's so much power available to us once we've got our heads around it, that I think it's a no-brainer. It's a new world, and it's a world that I really think should be coming. Not just because it's going to save the world and eco-friendliness and all that kind of thing, because I'm not all that eco-friendly. In the long run, I think we'll probably all be in space or living in virtual reality, like Elon Musk says. But because it just feels wrong, it's incorrect to be running at 10 to 15% utilization. It's clearly not the correct thing to do, and so we should do something about it. So finally, what I'd like you to take away is to go to labelschema.org and have a think about what labels would be useful to you and how you might want to make some suggestions about the labels that are going to go in for everybody. This is not a vendor-specific thing. This is for all of us. What tools would you want to write, and what labels would you need in order to write those tools? Then come and say, actually, let's start suggesting people that put these labels in, and have a play with getting your first badges on microbadger.com, which is all about doing the right thing and getting badges, like the Boy Scouts. Doing the right thing, get badges. It's all about badges. It's not in any way about badges. So put badges entirely out of your mind. This is all about badges. So that's me, I think. Use orchestrators. That is the key takeaway from this talk. Do I have any time for questions? Don't know if I do. I think I might be handing over to the next person. There we go. Okay, thanks.